Don't worry, we're live now. I'm sorry, I had to get a little bit of artisanal coffee. I had to participate in, I told you guys about Hack Baltimore before. I was wearing my little cape. We're doing a design jam session. Pretty dope concept. One day we'll go over it. But how's everyone doing tonight? I'm good. I'm having a great night. What's up, Como? How are you doing? Let me get everything set up here. What's up, Terrence? How you doing, man? It's a little bit loud. All right. What's up, Shanda? How are you? You hanging in there? I'm hanging in there. Yeah, tonight we're gonna Docker part 2. Tonight's gonna be fun. Actually, what's gonna be fun about tonight, I'm gonna talk about it a little more later, but what's gonna be exciting about tonight is I made the statement last time that people don't the things that we're learning right now, we're learning the core concepts of Docker, and all these things are super important. But the way that people manage containers now isn't generally, like when you're developing and stuff, you'll be doing it this way. But you kind of you're generally gonna be using tools, bigger orchestration tools to manage your Docker containers. And so tonight's gonna be interesting because from the last time I checked, Docker has come a long way. So from when I first originally learned it, so there's probably some cool deprecated things that I'm going to tell you to do, or old things, but we'll figure those things out. But some good concepts tonight. So last time we learned kind of the core basics. We went through a lot. That was a long stream. We're going to quickly run through the slides like in a couple minutes, and we're going to get right back into building containers tonight. We're going to try to take, I think what we're going to do is we're going to go over the couple of core concepts that we need to go over, things like persisting data, things like, linking containers together and things like that. And then I think after that, we're going to get just back hands-on building, like actually building a Docker file. I think I'm going to grab a couple of open source applications, and maybe we'll practice Dockerizing simple ones to kind of contextualize that again. Again, maybe the first thing we'll do is kind of build upon our Nginx one, just so you can see, again, we're just building upon concepts. I think it'll help. I know we're tired of seeing and using Nginx, but we'll grab something. We'll grab something that doesn't need a whole bunch of stuff, and we'll build, even if it has a Docker file already, we'll build one out for it. And we'll have some fun tonight. Tonight will be good. So what exactly are we covering? I think I put the bullet point topics in here. We are covering container management. So we learned a little bit about container management last time, a very little, small amount. Those are things like, starting and stopping and removing containers and removing images and things like that. So we'll talk a little bit about container management. Persisting data is the big one. Data persistence is probably the single largest container oddity or issue that people kind of have to deal with. And there are paradigms for that. And then we'll just talk about, some of the do's and don'ts of Docker, and actually practice it before we get into the orchestration. I think it's important that we understand it before we get into the orchestration. But yeah, only other thing that I want to throw out tonight is that, we are streaming Friday. Terrence and I are going to be doing Overwatch and office hours on Friday. So if you have any questions, come on through. We're going to be playing some games. You'll probably watch me try to get better at Overwatch for the first, 30 minutes or something, and then we'll play some games together. But this one's going to be a little more structured. We'll have some specific times where we're just going to be there answering whatever questions. Also, just extending our conversations in tech. I think that stuff's exciting. Just to kind of relax at the end of the week, kind of a wind down, but also a time where you may be able to get some good information without all of the structured stuff of the boot camps. But just to relax and hang out and have a little bit of fun. I'm no good at FPS. Can I still be a DevOps man? Yes, you can, Uno Plank. I am also no good at FPSs. I'm better than I was, but it in no way will affect how good you are. How good you are at DevOps. Fortunately, because I'm pretty bad. Also, Halo 1 just came out for the PC, so we might have to play a little bit of Halo 1 because it's been a while. And Halo was my game. But okay. So we're not here for 3 hours tonight. Let's hop into it. Let's go over what we went over. So I'll give you the slides again if you need them, but we're just going to open up the same slides that we already looked at, just to have something. We just want to have something to refer back to, not necessarily to be memorizing cloud containers. There. With the link, copy link. Halo is legit. I love that they released Reach. I'm waiting for them to release Halo 2. Halo 2 is my favorite for sure. I think that'll be really fun. I think Halo 3's multiplayer and Halo 4 obviously is going to be better on the PC, but Halo 2 is where my heart is at. That's when I used to put unlimited hours in. It's pretty sad actually how many hours I put in Halo as a teenager. But yeah, so super quick, we're just going to go over containers. Just remember that containers are, these isolated ways to package up and run applications. Again, isolation is a big word here because that feeds into all the paradigms that we're going to need to do. You can package up all the dependencies and the libraries that an application needs to run. So everything an application needs to run, besides the operating system, is packaged up in these containers. They make for a consistent development experience and a consistent deployment experience, because once you package up or you build that image, it'll be the same everywhere you send it to. Again, isolation and security, rapid development, very scalable because they're small, and just kind of the way they operate. They're designed to be ephemeral, so you can, gather a lot of them or destroy a lot of them if you need to, and portable. Anyone's computer who's running the same version of Docker or higher as you can run your application as you created. You can grab anyone else who developed a Docker image, you can pull their image and it will run just fine on your computer. I'm not playing Overwatch on Linux yet. I might try to get that worked out before Friday. I'll actually have some time, so I might try that out. So containers versus virtual machines, we talked about that a little bit. Just notice that there is no guest operating system here. That guest operating system is something like a whole new installation of Windows or Linux or something like that, that our apps sit on top of. We don't need that. We no longer need to install a new operating system and install our apps on top of that. We just need to take our Docker containers and our Docker engine, and they can use that host operating system to get what they need. So that makes them a lot lighter, a whole lot lighter than virtual machines. Docker's not the only one. These are some other ones, but Docker, I wouldn't worry about diving into any other container technology right now. I think Docker has such a big community presence that this is what I think. I'm very confident in saying this is what you should learn. We talked about Docker intro. I don't think we need to go over that. Just know it runs on Linux, Windows, and Mac. I think these things are the things that are very important. Docker containers are designed to run a single process. Although they can run more than one process, they're designed to run one. And you're going to see that in the way that we kind of design things tonight, I think. But they're designed to run one. And that may be a little bit confusing. What if my application needs multiple things? We'll talk about that. And then containers are designed to be ephemeral. By default, they are designed to, not persist anything and just kind of go away. So you need to keep that in mind. Then we talked about Docker files. That's how you build a Docker image. So Docker files is basically the source code that we're going to write to configure our image. We're going to use the build command to build an image. We're going to use that image to deploy containers, as many as we'd like, and then that image can be tagged with a name. And a registry is a repository that holds our Docker images. So a lot of stuff, that's a lot of information that we just kind of ran through super quick. It's okay if you didn't remember the stuff. It's okay if you didn't tune in last time. This is your first time. I think you'll pick up some of the context as we're going through this stuff tonight. But we're going to get straight hands on. We're going to open up a terminal and we are going to get ready to do this. So what's up, Mr. Waffles? How you doing? What's up, FMO? Just had a software developer interview. That's dope. How'd it go? How'd it go? What was your experience like? I'm always interested. But that's awesome. Congratulations on the interview. Whether it went good or bad, use it no matter what. You know, if it went bad, you know, hopefully you were able to take away some good things, but I'm hoping it went really well. And you can use that as well, and, you know, really start to highlight the things you're really good at explaining, and maybe some things you weren't so sure about, but you did a good job with it anyway. Maybe you want to shore up those things, but that's awesome. Pretty fast. Well, it was more for college. That's awesome. They only asked one question. Yeah. Did they only ask one technical question, or did they ask a single question, period? And was it conversational? I'm always interested to know if it was just more of a conversation, because those are more fun for me. Oh, that's why you want to do the course. Okay. Hey, that's actually a good question. Kind of knowing what drives you, what's behind what you want to do, your motivation. Good thing to know. Hit my first phone interview for a remote job myself. That's awesome. Congratulations. Getting those interviews is one of the beasts. What's up, P Tret? Welcome to the channel. Thank you for the follow. But that's awesome. Did you feel comfortable? Did you feel comfortable in that interview? Or, like, I don't know how many other interviews you've been on before this, but was it a positive experience? Like, I don't know. I talked to some people who got super stressed out after an interview, whether even ones that went well. I hope that it was a positive experience for you. 15 minutes, very easy. Yeah, I love the first, especially remote interviews. I like remote interviews because usually the initial interviews for remote jobs, usually the first one is holds a little more weight than when the second one's in person, because you're like, all right, well, the way I'm going to be I'm already interacting with this person in the way that I'm going to be working with them. Generally, in my experience at least, the next interview isn't too crazy, but dope. I'm super happy to hear people out here interviewing. You know, again, good or bad, everyone should be trying to get out there. Put yourself out there. Talk to people. Try to get some interviews. You will get better at interviewing, and you will. I don't know. You'll get that job. You'll get that chance if you just keep. I don't know. Just keep putting yourself out there. It's hard. I know it's hard to do. I'm not saying it as if it's super easy, but I love that. I love to hear it. Yeah, I'd love to. Yeah, post it in here. We'll check it out. I'll check it out in a little bit. I'm gonna get started, but post it in. I'll definitely go on and check out the website. Issue with 5 years experience. We'll look at something, but yeah, I mean, the next step's always a good one too. All right, so let's see if we still have anything running from last time. Remember, how do we see what containers we have running, or if we have any containers running? And if I do a Docker PS, we actually still have containers running. 2 Nginx containers, and actually, let me see if this is too small. Okay, I like it better when it's really supposed to be like this. I'll make it a little bit bigger for now. I'll make it here. It's not too small. I'll make it a little bit larger, a little bit. But it's got all of our things here. It's got our container ID, our image, 2 Nginx containers that we ran last time. One that is running on port 80, but notice it's different from this one that's also running on port 80. And this is just a little indication that that this is mapped or exposed to, the exposed port is mapped to a host port. So this is the only one that's exposed. This one is kind of living, you know, behind the scenes. It's running, it's isolated from everything. It does have an exposed port, but that port is not consuming any ports on my host machine. Tonight, we'll learn how to kind of mess around with some of that stuff, as well as when we get into container orchestration. Let's start fresh. Let's remove these and see what. Let's start fresh. So remember, how do we stop containers? We have to stop them before we remove them. So let's stop them first. Docker stop, or I could do Docker kill. And remember, you can just do Docker stop, and you can either do, you can do 2 things. You can either use the container ID, which is these, or you can use the name. So I'll show you with the first one that you can use the container ID. So Docker stop, I'll stop that one, and it kind of gives you a little output there. If I do a Docker PS, you can see only one is running. And same thing, I could have run that command that we did last time to stop them all, but I just wanted to show you that you could use the name or the container ID. Doesn't matter which one you use, they both work. They're both uniquely identifying factors for these containers. So if I do a Docker PS, we are good to go. We have no running containers. But how do you see all the stop containers? We've learned last time that containers, containers, they when you stop them, they aren't gone. The process stops because it's not like it's running a normal application. It's a container. It's a contained application. So to see all of them that have been running, both ones that are running and ones that have been stopped but still exist on the system, go ahead and add in that -A flag so that you can see them all. And we removed all the other ones last time, so we can see these here. Cool. I don't need to remove those. Well, actually, we'll remove them. We will remove them because just to keep everything clean. So let's do Docker RM. And again, same thing here. You can use either the ID. And remember, RM is how you remove a container. It's very important. RM removes a container. We'll talk about removing images again in a second, but that's RMI. So that can be confusing. That was confusing to me in the beginning, remembering which one was which. Also, at the same time, trying to remember what the difference between a container and an image was, but don't sweat it. I'm just gonna keep saying it out loud. That's why I keep repeating things out loud to just drill it into your head. So we'll run that same Docker PSA command. See that we still have one. I'll copy the name again this time. Since I did the container ID last time, and Docker RM. All right, actually, let's take a look at this. Was built off of the Nginx image. So just let's say we tried to another important concept to just reiterate. What if I tried to remove an image? So if I want to see my images, I type in Docker images. And I can see here, we built this one last time, but we have an Nginx image that's right here. Let's say I wanted to get rid of this. Let's say I didn't want this on my computer anymore. The way that you remove images is Docker RMI, and you type in the name of the image. And if I type that, I get this error, and it sucks. And it's like, oh, unable to remove repository reference Nginx. Must force container. This is using its referenced image. I can go ahead and I can just do a Docker RM. That is a reference to this stop container. You can see this container ID is this. So just remember, there are ways to force this, but you should remove all the containers first before you delete the image. So let's do that. Docker RM, we'll do this. And since this is the DevOps bootcamp, let's add in some of our Linux stuff. How do we string commands together? We can do this double ampersands. We can do Docker RMI, and we can do Nginx. We're probably gonna need this again, but it doesn't matter. So to run this command, the double ampersand says, hey, as long as this one runs successfully, go ahead and run this one over here. So run that, and it looks like we didn't get any errors. And if we look at our images again, there's no more just regular Nginx image in there. So that's basic. That's some basic Docker management. We're gonna be doing a lot of that throughout tonight. Period. I'm actually gonna remove. I'm gonna remove everything. I'm gonna remove everything. Docker RMI. We're gonna start extra fresh, the most fresh. What was it? Docker. Can I do this? Images. Do I have to add in the -Q here too? I don't know. There we go. All right. So Docker PS, no containers running. No images. I have no more images on my computer as well. So I deleted everything. We're starting fresh. That should avoid some of the confusion when going through some things tonight, and we are going to be good to go. Now, let's talk about the first big concept of Docker. And let's head back over to the Docker documentation so we can have a reference here for you to see and that you can read through while we are going through this stuff. Docker, sure, Docker run reference is fine. This should be all good. All right, so first thing we're gonna talk about tonight is data persistence. Data persistence is a problem in Docker. Remember, these things are isolated. If I were to spin up a Docker container, and now again, just to do some practice, I don't have any images right now. But let's say I just wanted a base Ubuntu image to just play around with. I'm going to do Docker pull Ubuntu. And how would I know to do that? How would I know what the image name was? Don't forget our handy dandy website, hub.docker.com, which is your main source for everything you need that is Docker related, I think. Again, you can have other repositories that aren't the Docker Hub, but this is where everything comes from by default. Your Docker, when you download it, is automatically set up to pull from here. So if you were trying to find something, again, this is where you would find it. And I want an Ubuntu-based image because I don't know what I want to build yet. But I want to try some stuff. Let's talk about Docker. Let's talk about container and data persistence really quick. Darn it. So Docker pull Ubuntu is how I would do this. I can copy and paste this, not letting me copy for some reason. Probably has to do with my little server thing. So Docker pull Ubuntu is how I'm going to do that. And I'm going to hit enter. And just like that, it's going to go and it's going to download stuff. And super fast. Remember, we said containers are quick. I pulled that very quickly. I can do Docker images to confirm that I downloaded it properly. You can see that's only 64 megs. And just to reiterate that this is not the Ubuntu operating system. It is simply a container that has the tools, some of the tools that you're used to that Ubuntu uses. If we went to ubuntu.com, just Google Ubuntu, and we try to download from here. I'm not going to download it, but if I click on Ubuntu 1910, this thing right here, I'm not donating. Let's see if it tells me how large it is. This thing is 2.3 gigs, and actually that's going to break my server. Big mistake. Cancel. Okay. So you see that? That's a huge difference. 2.3 gigs for the entire image. Ours is 64 megabytes. Again, why is that? That has to go back to our Linux discussion and knowing that Linux distributions aren't actually different versions of Linux. They are all the Linux kernel, the engine that allows Linux to run. They all share that thing. And a distribution is simply just a different packaging of applications and tools, libraries and binaries on top of that kernel. So that is kind of what this is as well. It just gives you some nice tools to play with. So we're going to be talking about a lot of different things, tying lots of different things together here. So I have that downloaded. I have the image downloaded, and the image itself, again, remember, it doesn't really do anything. I have the image downloaded. But what I want to do if I wanted to run, start up a container based off of this image, hit you with the Docker run command and type in Ubuntu. So this is the default setting for running a container. Docker run the name of the container, or the name of the image, not the name of the container, the name of the image. And that will go ahead and kick off an instance. It'll kick off a container for us. And if we do that, it exits and you do a Docker PS. And again, you can see that nothing's here. But I can do a Docker PS-A to see if anything actually started. As you can see here, started and it exited. This has everything to do with remember the anatomy of a Docker file. And I think we have a Docker file here. Mastermind, streams, DevOps, Docker. All right, check out this Docker file that we have here. I don't have anything in here. This wouldn't work either. But remember we said there was a, what's up, JB Nunn? Welcome to the channel. Remember we said there was a CMD command and there was an entry point that you could only have one thing in here. They both specify either a command that's when you want to make your container an executable, a command that's going to run, or an exec basically command to pass in. You can only have one of each of these, and actually there's some overriding that happens to this process. But the Ubuntu container, I'm not going to save this. The Ubuntu container that we just ran It's actually just set up to do really nothing. It's designed as a container for you to be able to build from. It doesn't really do anything, again, besides provide you some tools to build with. So me having this is kind of useless. But what if I wanted to just start one up to play with and start figuring some things out? Remember the flags that we talked about. How do we start a container kind of in the background indefinitely? So let's put some commands together. And this is a common container command that you're going to do when you're running things locally and you want it to actually be running. You want it to stay, running in the background. This is the command that you're generally going to do. Docker run -itd. We'll talk about what those are in a second. And then the name of the container that you want. Actually, let's go ahead and clear this out. So here we go. Ubuntu. This is generally what you're going to want to do to keep a container running. Whether that's good or bad is one thing, but this is generally what you're going to want to do. Docker run -itd and the name of the image that you want to deploy this container off of. So what is the ITD? And again, we could look at the man pages for this, but this is like, again, just kind of get ITD in your head because this is something you're gonna do a lot. The I, again, we talked about this last time, is for interactive mode. This allows you to be able to interact with the container itself, and it allows it to, give you feedback, you to give it things. But even though interactive mode is enabled, if you were to do this without this next flag, if you were to do it without the T, you would not be able to interact with this container with your keyboard. The T gives you a TTY, which is teletype. It allows your keyboard to work basically with the container. And then the last thing is D is for the detached, or again, I think of it to run it as a daemon, basically run it in the background and kind of keep it going. So if I were to do this, remember the dash D, we looked at it last time. Not only does it detach it and run it in the background, it also prints out and delivers to you the container ID. So if I do a Docker PS now, we actually have a container that's running, and it has an entry point command, or has a command that it kicked off, which is bin bash. So now we have a running container, and again, it's not really doing anything. There are no ports. What's up, Hug ODC? Welcome. What's up, Lionel? I'll wait till it pops up. I missed that one. I just want to say what's up before I need to get something that kind of keeps everything in order when I don't get to, welcome people, but welcome to the channel. Good to have you. So we do have a container that's running now. We have just a default image that's kind of running. And again, this is still Linux. Like, these containers aren't anything crazy special. They are basically little packaged up runtimes that allow you to use your computer's kernel, your host system's kernel, and the Docker engine to kind of emulate an environment almost. So we can actually log into that. Remember, how do we log into it? It's not really logging in, but again, think about it like logging in. We can use, again, that exec command -IT. So it's already running, but we still need to do, we need to do an IT. And then we need to do the name of the container, so sad Maxwell, and / we need to tell it what command to do this, to execute against it. So almost all the Docker commands are going to be something like this. Docker to execute, the Docker executable. Then the thing that you want to do, so sometimes it's run, sometimes it's exec, sometimes it's PS, but so it's going to start with Docker. Then what you actually want to do, and you can run, you just type in Docker, it'll give you all the commands that you can run for this step here. Then you're going to pass it flags. So we're going to pass it these 2 flags. Then it's going to ask for so it could be way more flags than this, but right now these are the only flags. Then it's going to be the name of the thing that you want to either execute upon, or the image, or whatever your kind of target is. And then for an exec in particular, then there wants to be the command that you want to run. Remember, this exec is not how you log in. This exec is how you run a command. You execute a command in this Docker container. So it could be anything. It could be an ls. It could be a netstack command. It could be whatever you want. But bin bash will allow us to attach to a shell that is in this container. You can see here now we're in the container. So what's interesting is if I type in, not Docker PS, if I just type in a PS, dash AUWX. It doesn't really give us anything. It gives us a PID1, which is bin bash. So what's interesting is your entry point, your command or your entry point, depending on how you have it set up, will always be the PID1. The PID1 is the one that matters the most. PID1 is like the essential one process that is that this is designed to run. Bin bash is the one we executed. There's another one. So this is actually the one that we executed. So it started up with bin bash, and that is this one right here. And then the process that we're actually inside of right now is this process. And then it's actually showing the PS command that we actually ran. So there's nothing in here. Imagine me running, if I do a PS AUWX on my computer, look at all the stuff that I get. There's all these things running on my host machine. A whole bunch of processes are on my host machine. And if you did this inside of a VM, you would see the same thing. You would see all of this stuff. So this is your first indication of why these are small and quick and scalable very fast. And why the overhead is a lot less, because it doesn't need to run all that other stuff, because my host machine is already taking care of all that stuff. It just needs to run the stuff that's essential to run whatever applications that it's designed to run. So now that I'm in here, I can do, again, a bunch of stuff. I can do apt update, stuff like that. So all the things that you're used to, all the things that you learned in the Linux streams, you can run these things. Well, mostly. It's going to be missing a lot of tools, but you can install those tools. It's going to be it kind of gives you just the essentials. There's going to be a lot missing. Again, remember last time we didn't get Vim or VI by default. Actually, I don't think we have a text editor at all in here. You would have to do it through like echo hello into a file, unless you wanted to install Vim on here, but that is something that you could do. But I wouldn't really recommend it unless it's going to be something you're doing all the time. So that is yes, so we were able to run this container, this kind of base image, off of this base Ubuntu image, and we were able to kind of log in and kind of see what's going on. What I want you to get out of what we've done so far is, one, remember the flags that I added. Don't necessarily remember exactly, don't kill yourself remembering exactly what those flags are and what they do. You should remember it, but remember that a container is designed to run a process. And by default, it's designed to really just execute that process. And then when it's done, it's designed to kind of exit that container. To override that or to bypass that, you have to run the container in a certain manner, telling it to, hey, I want you to detach yourself from the run, and I need you to continue to run. I need you to be set up in a way that as long as this process stays running, you're going to stay up. Instead of just kind of executing what you need to execute and exiting peacefully, because that's not what we want to happen. Sometimes that's what you want to happen. A lot of times that's what you want to happen. But if there are times where you need a long running process, you have to do something like that to get it to go. If we were just doing like a script or something, if we had some kind of script we wanted to run, we could just execute it without those flags. We could, in fact, just do a Docker run, and I can put a script in here that does something if we want. And it will just execute that. So I think if you do like a Docker run, like hello world. So I ran Docker run hello world. Hello world is actually a package that exists here on the Docker Hub. Something that we did not go over is that if you run Docker run and you specify an image, that is not local to the computer. So you never saw me, you saw me clear out every image. You saw me execute everything. But what you did not see me do is download the hello world image. If you do a Docker run and specify an image that you do not have locally, Docker will actually say, all right, I don't see this image locally. I'm gonna go and check the repository or the registry that you have set up, which is the hub.docker.com, and I'm gonna go ahead and pull it. So it will pull that data. So you could actually do Docker run Nginx or whatever without downloading it first, without pulling it first to do that. And so it ran. This container is designed to basically just execute these things here, just this information for you, and then it exits. So if I do a Docker PS, that container is not running. And if I do a Docker PS-A, it did everything that it was supposed to do, but it finished its job. X about a minute ago, it executed a command that was /hello. So the other ones did bin bash. This one is designed to run a command at /hello, and then we get a bunch of stuff here. So I'll stop there for a second. I see a lot of chat messages. We'll go through them, and then we'll move on to the next piece of persisting data, of linking containers together, all that sweet stuff. All right, so has someone experienced a major link security modules developing them? No, I don't. I do not. You can also use the first unique characters in the container instead of the ID. Yes. So the ego says you can use the first unique characters. So if I do a Docker PS here, Docker PS, you don't have to type in all of this. You can just do if I want to stop this, I can do Docker stop and just do a 2. Since this is the only one running, I can just do 2. If there was another one that started with a 2, I would need to give it enough unique characters for it to know that this is what it refers to. If I do Docker stop 2, it'll go ahead and it will stop it. That is something I just learned recently, which is super dope. So that's dope. What console am I using? I'm using, wait, where's it going? I'm using Hyper. Terminal. There you go for the link for my terminal. I'm using Hyper here. Trying to roll back in your terminal. Sorry about that. Can you use it on Windows? Yes, you can use Hyper on Windows. My settings are also in terminal config. I don't know. Maybe that's not it, but there's a chat command for setting up your terminal like my terminal. I'll probably switch it up soon, to be honest. Getting tired of it, and I like things to be pretty and exciting. Use PS or CMD if you have Docker for Windows. Okay. This tool's not about the Linux kernel. Yes, that is what I meant. I don't remember what I said. How do you persist changes? So we talked about that a little bit last time, and that is good. That is good Docker management. Let's actually say, let's say we did in fact start up an Ubuntu container, and we made a change to it. So -it. Let's say we did go in here and we made a file. Let's say right here we touched test.txt and we echoed hello we put some text into it. So now if we cat it, there's files in here, and we got out of here. The way that you would persist this, the way that you could persist this, the way that you shouldn't persist this, but the way that you could persist it is to do a Docker commit. We talked about that last time. And what Docker commit will do is you do a Docker commit, you'll specify the image, the container that you want this to be based off of. You'll specify the name of the image that you want to create, and it will create an image based off of this running container. Again, you can do that if you need to. You should not do this. Well, you shouldn't do this. You shouldn't do this if you don't need to. And there's very few situations that you would need to do this. Why shouldn't you do it? You shouldn't do it because you lose a lot of the benefits of Docker. You lose the ability to be able to rebuild this at any given time. You lose that documentation. You should be building these via Docker files. If I need a test.txt in my file, I should be building a Docker file that copies a TXT file into my Docker container rather than doing it this way. But Docker commit is how you would do that if you needed to do it. But again, I don't recommend doing that. Don't recommend doing it. Let's see. Stop and kill all containers. Yeah, that one's interesting. It's something like Docker stop. And if you do a $, this is to basically, in Linux, if you do a $, and then put something in parentheses, it's basically going to evaluate what's in there and basically use it as the argument over here. So it will be Docker stop, and then you would do basically a Docker PS, will basically list out all the things that are running. And I think you just do a -A, like -Q, and it will stop all the running containers. And you can see it does that. But it also tries to stop containers as well, because I did the -A. Without the -A, it would only stop the running containers. But there's a couple different ways to do it. You can pipe it to a Docker PS to xargs, and like it's a bunch of Linux foo. It's not really Docker out of the box. I don't think provides you a way to stop all running containers. All right. Thanks for teaching me Docker. Went down a rabbit hole with Rancher. Yeah, you can't go right down. You can't go straight up on Rancher or Kubernetes. But I mean, I think it's really good to have a good handle on Docker before you get into those things. All right, so let's talk about persisting data. So remember, everything you would have would be in these containers, the stop containers. I could restart those containers, but again, they're designed to be ephemeral. They're designed to go away. So we don't want to save data inside of these containers. The thing that's not ephemeral is the host machine's file system. So the way that you persist data, or the way that you commonly persist data on for containers, is basically you attach a volume, a local volume, a local directory. You basically attach it to a directory that is inside of the container. So this used to be done, well, it's still done the same way, but Docker has something called volumes now. Docker volumes basically create a nice little paradigm for you to save things locally. And so they do it in a way, like it does it in a cool way so that it kind of makes sense in terms of Docker and Docker Compose. But basically all Docker volumes does is sets up a little proxy for you to be able to save stuff locally. So let's talk about that really quick. And so if we do Docker PS or just do Docker, we'll see what options we have available to us. And management commands, a bunch of stuff here. Docker volume, so you can manage Docker volumes. So let's talk about that right now. Okay, Docker volume. We'll see what commands we have available to us with Docker volume. Docker volume, manage your volumes this way. So I can create a volume, I can inspect or detail information about a volume. I can do an ls to list volumes. I can prune volumes, so I can remove all local unused volumes, which is nice, and RM to remove volumes. So these, again, they're Linuxy commands that you're kind of used to, like ls to list, RM to remove. So let's do a Docker volume ls, so we can see if we have any volumes currently, and we do. So when you create these, when you create some of these things, these are actually older. None of these I don't think are from anything that we've done so far. We haven't done anything that would warrant this. You saw I had all those images before. I've done some other Docker stuff on here. Those tasks created volumes for us to use. So it basically gives us a local spot on the computer that we don't really need to worry about where this stuff is saved. You do have control over where that is. You can actually go there on the file system. But again, this creates a nice little paradigm to kind of create a place where your containers are saving things locally to your host machine. So this is very similar to how you have the container, which is very isolated, and you expose a port, right here, and you connect it to the port on your host machine. This is kind of the same thing. This is the data that's saved here is basically going to be connected to the host machine to another save spot, so that we can keep that data when that container goes away. So first thing I'm going to do is I'm going to remove all these. How can I remove all of these? I can use the rm command to delete one. So let's practice that really quick. Let's do Docker volume rm, and we'll just select one right here. I'm pretty sure I can just do it like a 9 again, just like this. Oh no, I guess for these, you got to do the whole thing. All right. And you can see that removed it. And if I do another Docker volume ls, that top one is gone. But remember, we have this sweet prune command, and it removes all unused volumes. These got to be unused because you saw me remove all the containers and all of the images. So Docker volume prune. This will remove everything basically, and click yes. It says this will remove all local volumes not used by at least one container. So I removed it, and I got some space back. So this is great. Got a little more disk space. And again, throwback, how do we check disk space? I can do a df-h. Not really important right now, but again, just practicing some of the stuff that we've learned so far. So how do we create a volume? So there are things you can do when you run a command to create a volume, but the way that you create a volume is with the volume create command. So I can do docker volume create, and I'll just call this one stream volume. This should go ahead and carve out some space on my local hard drive for me to attach Docker containers to. And if I do a Docker volume ls, you can see here I have a local driver here for stream volume. So now I have a space I can connect things to, which is dope. So because I created this first, I could run a container really quick. I could run a Docker container real quick. But let's see if we can figure out how I would specify in that run command how to use this volume. When I run the container, I got to tell it which volume to use. And down here, basically it's a -v, and it says bind a mountain volume. So I'm basically going to pass in a -v flag, and then I'm basically going to give it a place, the volume, and I'm going to give it the place to attach it to in the container. I'm going to give it the where in the file system this should be attached to in the file system. So let's check that out. Let's also see if we can find an example inside of the documentation, because I do think that is I do think it helps being able to again go through these things the same time we're doing stuff. So this is an example, but this isn't the main section, I don't think. Here we go. All right, volume, share file systems. So we're gonna pass in a -v. I thought there would be a good example here, but there's not. Or was there? All right, well, we'll just do it. Oh, well, yeah, it tells you what to do here. Volume, the host source, and then container destination. So here's what you'll do. We're gonna run that Ubuntu container again. We're gonna run it again, and we're gonna do docker run -itd. We are going to run -v, and we're gonna give it the volume name. So we called it stream volume. I might do an equal sign, I never remember. Then we're gonna do a colon, and the place that we want it to mount to inside of the container. So it could be any directory. It could be like /mount. So we could do this, and we can do Ubuntu, and then yeah, we'll just run this. So same command as before, docker run -itd Ubuntu, but this time we're adding in a new flag, a -v, and then we're giving it the volume that we want and the mount. So let's see if that works. It looks like that works. I can do a docker ps. So it's running, it's up and it's running. But I can also, forgot to tell you guys, you can do a docker info too. If you want to find out more information about the thing that you're doing, the thing that you are running. Whoops, docker info, not docker info. I don't think that's what I wanted. I wanted docker. Hold on, I always forget. I never manage individual Docker containers anymore, so I never remember. Let's see, docker pete, docker. Thought I could do docker info. I could do logs. How do I find out? Wide. How do I find out specific information about this container? I thought there was a command to do it. Docker. I don't know. Is there a way to do it? I don't remember. This is the resource usage. There's a way I can get all the information about the currently running container, but I don't know. Docker. Oh yeah, docker inspect. Thank you. Appreciate it. Docker inspect. And darn it, Hold on. Docker inspect. I bet I can do this. All right, cool. So if you do a Docker inspect, you can get individual information in JSON format, hard to read by a person. Do I have JQ on here? Let's pipe it to JQ so we get some colors. How do I do pipe on this keyboard? There we go. Never remember. All right, so we get some cool colors, but we can see this JSON here. So we can get information about our container, lots of information here. But you can see that, you know, the path that's running, the ID, lots of good information here. The image that we used, the log path, all of this stuff. But in here, there should be mounts. So here's the mount that we did. I can show you one. I'll run one without the mount and then in a second. But the mount that is set up is a volume called stream volume. So that's the one that we created. The source is here. So this is actually the place on my local computer that this information is going to be saved. On the host machine is where this stuff is going to be saved. This is the destination on the container that it's connected to. So whatever I put into the mount directory here will go into this source, like it'll actually be saved here on my computer. And I'm pretty sure it works vice versa as well. I'm pretty sure I could put things in my host machine here and you would see it inside of here. The driver is local. Yeah, so you can get that information. You can also find out other things about your running container. Okay, thank you for that, Doug Muffin. So now that we have this running, let's log into it. Docker exec dash IT slash. All right, so we put this at /mount. So I'm gonna go into /mount, and there's obviously nothing here because no one's ever put anything in that volume that we created. But let's go ahead and let's put something here. So again, we're gonna touch a test.txt, and we're gonna put something in there. I am Aaron, and I was here. And we're gonna send that into test.txt. So now that actually has something in it. If I cat test.txt is there. All right, great, excellent. Everything's all good here. So how can we confirm that this is a thing and that this is working properly? So the currently running container is Vibrant and Tonelli. Excellent. All right, so let's go ahead and spin up another container, another Ubuntu container. I'll teach you another flag that you can pass in. And actually, I don't even know that this is the right flag. But we can give the container a name. So it will give it another name. But let's give this one a name so that again we can practice more things. I think it's a -x, or it's either a -n or a -x to give it a name. I think. Never remember these hostname string. Or was it -h? Maybe it's a -h. Maybe your boy is wildin'. Maybe he is. Okay. It's -h. Again, you're gonna forget all this stuff soon, but you should learn this stuff. All right, let's do -h here. Let's see if that works. Seems wrong though. What's up? I think I said Izzle on Twitch. I didn't say thank you for the follow. Welcome to the channel. Thank you for the follow. And Ronan Bites. That's a cool name. I like Ronan. I like Bites. Welcome to the channel. Thank you for the follow. Let's go ahead and create another. Go ahead and let's run. Let's run another one. Let's give it a name. -h for host name. And we'll call this volume test. I think that'll work. So we're gonna run another Ubuntu image. And here we're gonna use the same volume. We're gonna connect to that same volume. All right, so another one spun up. Okay. Oh, so okay, that just said the host name. That did not set the actual name. What is the actual name? Let me just, I'll delete it once I get it. Is it dash, is it dash N? No, is it dash X? How do you say her name? Let's Google it. I know one of you knows. This is weird. Docker run that name. Well, you can link via host name. Oh, it's dash name. I didn't know that. I did not know that. That's whack. I don't like that. I don't like that at all. Are they tricking me? Are they tricking me? Did they lie to me inside of this thing? Why did they do this? It's not all that important right now, but like what we're trying to do. Oh, it's dash dash. Okay, so they did lie to me. They lied to me. All right, that was whack. Cool, it doesn't really matter. Now we have 3 containers here. Remember, Vibrant Antonelli is the one that they spun up by default. This is the one that we spun up second, and volume test is the one we just spun up third. Let's go ahead and log into volume test. Docker exec -it volume test /bin /bash. We connected them all to the same mount point. So if I go into this container, this is a brand new container, fresh container that doesn't have anything in it. If I go to /mount, check that out. We have a file that already exists here. Brand new container, file already exists. We cat it. I am Aaron and I was here. So we're able to connect to a shared drive for one. So that's nice. You can connect multiple containers to the same volume, which is excellent. So you can share data, you can persist data between them, which is super duper cool and very important, something that you need to do a lot. And just to show you that if I spin one up without using this volume, oops, it won't let you spin up 2 containers with the same name. That's what the error we just got was. I left the name in there. It has to have a different name because this is a unique identifier. So we'll get Gallant Allen. So let's log into this one, which does not have it does not have the link, and we can confirm that by doing again the Docker inspect Gallant Allen, and again let's pipe that to JQ, and if we scroll up a little bit and find the mounts, there's nothing. There's no mounts in here, which is nice. It's completely empty because we did not mount anything to it. Super duper nice. No mounts. So if we log into it, what's up, Dalius? Welcome to the channel. Thank you for the follow. It's so good to have you here. I really appreciate it. So Docker PS Docker exec exec -it Gallant Allen /bin. Actually, what do we need to do this? We're going to use exec. Let's check what's in the mount directory. So we'll do ls-la/mnt, and we get nothing. We get an empty directory because we did not attach anything to this container, just to show you that stuff is saving. So check this out as well. Just to show you that this is persisting data. Let's stop all of our containers. Let's stop every single one of our containers. So Docker stop $. Actually, I think we already did this. 20. That's gonna stop all of our containers. Now we're gonna remove all of them, so we can do that as well. We removed all of our containers, so we do Docker PS-A. So we wrote some data in a container. We were able to see it in other containers. We just removed every single container that we had. But if I spin up another one, if I do another run, and let's call this one volume after delete, and we run this. Oh, whoops, that's actually not gonna work. Let's stop that because we did not attach it to anything. but after delete and add it back in the -v, -v, let's call this volume test 2. We'll call it volume test 2. And we're mounting it to that same mount. That mount still exists. And actually, how can we see that that mount exists? Again, how do you see volume mounts? You do docker volume ls. And that mount is still there. It still exists. It does not get removed when the container gets removed. Now, you must be careful, because remember the commands that we had available to us. That docker volume prune command, that deletes all volumes that aren't attached or being used by any container. So if you were to run that, you would in fact lose this data, but we didn't run that. So we're not worried about it too much. We can just do, again, that -v, change the name to like to, and when we run this, after we removed all of our containers, if we exec, this one is called volume test 2. If we check what's in mount, look at that. The test.txt file is still in mount. We have officially persisted data. Again, this is great. This is great because, one, these containers are volatile. So they're not volatile, they are ephemeral. So there are times you're gonna be running a lot of these and they're gonna be swapped out. So it's very important that you keep this stuff somewhere in case anything happens like that. If you need to make any updates or anything like that, a new container is gonna need to be deployed. You're basically gonna be building those with Docker files. So you should, anything that you need to save to keep around, you should connect to a volume outside of here. You can mount more than one volume to these containers. You can also, again, mount multiple containers to a single volume. So it's great. So this is how Docker handles this. It allows you to bind a container, bind a local storage area to the container itself. And again, it's called a Docker volume. And yeah, you got a little bit of information. You can also inspect these. If I do a docker volume ls, I can also do a docker inspect, a docker volume inspect, and then stream volume. I can look at it and it'll just tell me where it is. This is where it is on my local machine. So if I do an ll, paste this in, well, now I need to do sudo. Actually, how do I do this? Is it sudo bang bang? You guys teach me something all the time. Okay, opposite. Is it sudo? Now I gotta, if I do this and then I do bang bang sudo. I should do that. What? I broke it. It's fine. I'll just do the real thing. And then I'll read, because I know you guys told me what to do. Oh, because all right, there we go. So if I actually check the local, place where everything is saved, you can see that this is in fact local to my computer, and I have access to it. I can change it here if I like. I can remove it. I can retrieve it. I can put other things here, and my containers would then have access to them, which is great. That is a very important thing that you need to know. Data persistence is pretty important. So let's check this out. Yo, Izzle on Twitch. Thank you for the Twitch Prime sub. Welcome to the family. Go ahead and hit the bang. You do ! Discord. You'll get access to the Discord channel, which has information about how to access the Google Classroom. That has some extra resources inside of it. So check that out for any new subscribers that are on here. So yes. Whoops. Let's go back. Where'd this go? There are different drivers. That this local driver that you see here, again, it references local storage. There are other drivers that allow you to do different things, so you don't have to save. There are other ways for you to manage this. And I wonder if they've released any more since the last time. I'm usually using local or like an EF, well, almost always local, because now we just use EFS or some kind of NFS mount that's mounted to a volume, so we can just do that. But Docker volume drivers, I wonder what the exhaustive list is. Storage drivers. Overlay 2 is the preferred storage driver. These are just the those are the drivers themselves. I remember having lots of issues with like device mapper, and it's gone. That's good. There was a lot of issues with like non-cleanup on device mapper stuff. These are options that we have. I want to see what else is on here. Yes, so these are options you have. We're not going to dive into these right now because this is going to have you need to know a little bit more about storage, which I don't think is important right now. And I hate when I see ZFS because that's that interview that I told you I closed the laptop on. It was a question. Whatever he was asking me, it was straight about ZFS. I still don't know that much about ZFS. I know a little bit about it, but not a ton. Don't need it for what I do. Okay, do something with one of our products. Mount a shared Windows machine. Yep. Great gentleman. Appreciate that, Izzle, man. Even though you're already gone. Hopefully I'll see you tomorrow. 2 dashes. Single letter is on tag. Oh. Can you show us an example of mounting multiple volumes to a container? Yeah, I can do that. Which I've actually never done with a Docker run command, but I can simply, I'll go ahead and I'll create another volume. Docker volume, create, Docker volume creates, Docker volume create, Docker volume create. What do we call the first one? Stream volume. We'll call this one double volume. I don't know why that seems better, but again, if we do a Docker volume ls, we can see we have 2 volumes here, and if we run our last command, what's happening here? Okay, I'm gonna start up a new one. We're gonna call this double volume. We're gonna name the container. So we have dash v stream volume. I think you can add either another dash v, or I think you can like do like you can put it in like brackets or something. But let's check this first. Because I've never done it via this way. I've always done it in like Docker Compose or something. Let's check. Double volume, and map that to, also I'm gonna map that to slash, maybe home. All right, and so I just added in 2 dash V's. There might be a way to do that in one command. So I just simply added another dash V. If I do a Docker inspect, I can confirm that it did in fact mount these things. The Docker inspect, we call this double volume. Which nope. We don't do things without them being pretty. So we're not looking at clean JSON. It's beneath us, to be honest with you. So if you look at clean JSON every day, I'm sorry, but we don't do that here. We look at beautiful Joker colored things, purple and green, because it's better for the eyes. It's better for the spirit. Feels a little bit better. So let's go up and let's see where our mounts are. We have 2 now, 2 volume mounts, 1 mounted to double volume, 1 mounted to stream volume. I could add more as well. And again, you can map any number. I'm sure there's a limit to these. I don't know what the limit is, but you should probably find with whatever you want to do. And I can use it just like that. So I can mount multiple things. So maybe you have some type of application that is, maybe you wrote a Docker container that has a script inside of it that every day it pulls down some data. Maybe like you have a bunch of users going to a site who submit their information, and it all goes out to like a S3 bucket or something. Every day you want to download that to your computer. Now this seems like a hassle. I wouldn't create a container to do this, but maybe you have a container that downloads that information. If you want it to stay on your computer, you may do something like this and attach it to a volume to make sure that when it's done and it dies and it's finished its job, it's available for you somewhere. But yeah, just that is how you do that. If you need, maybe if you had like a website or something and you didn't want to keep copying the website files into the container, you could have it, attached to a directory on the machine or something like that. Pretty nice. Lots of stuff you can do with that. Cool. So we did that. We're going to dive a little bit deeper in a second. Does anyone have any questions so far about persisting data to a Docker container? Because it really is a big concept. You will likely be asked about it in an interview if they ask you anything about containers. There are other ways to do this. Well, there are other elegant solutions people have come up with to do things. I've seen people do some wild stuff with S3, like I think very brittle, and this is kind of just it makes sense. It's kind of nice. Sure. If you volume prune, do you delete shared files? Yes. Docker prune, the prune command will delete that whole volume and everything inside of it. But it will not remove if you're sharing this. You are sharing a volume with another container that is still running. It will not delete that volume. Prune will only delete volumes for unused. It will only delete unused volumes. But it will delete all that stuff. So be careful when you're using prune for sure. But it will. So it deletes those volumes. It does not delete. I don't think it deletes the files though itself. Actually, let's check that out. I'm not 100% sure, but I'm like 99% sure it does not delete the files from your host machine. I'm pretty sure this will still exist. I'm pretty sure. Maybe I'm tripping. I don't know. Let's check. This is why you do it live, because it's great and you can do that. So I'm going to do a Docker. We know there's nothing in double volume, but we know there's something in volume test 2. Do we know is there something in volume test 2? No, these are not the volumes. Let's stop these first. Let's stop them. Let's remove them. Let's Docker volume prune. And let's do an ls dash, and let's see if this is still here. Okay, this directory is not here, so I guess it does remove even that directory. I wasn't sure. That directory is gone. It's gonzo, which means everything's gone. You pruned it. I guess that's why they give you a little thing here. This is yes or no. Yeah, look at that. Delete all the volumes. Everything's gone, so be careful with that. You do remove everything. Little dog treat thingy broke. I haven't wanted to buy a new one. What's up, Monkeyinator? Man, y'all have some clever names. I like it. I like it. Welcome to the channel. Thank you for the follow. I think someone followed right before that. I'm sorry I missed it, but welcome. I'm glad you're here. I do appreciate you. I promise. Okay. All right, so now let's practice writing some Docker files. I think writing Docker files are the thing that people are most afraid of, and I think this is good to know. Like, you've kind of learned the major pieces of containers. There are many more caveats that you'll learn as you kind of work with them. Again, they're not. They aren't perfect representations of kind of your normal Linux system. They have their quirks for sure. But let's build a Docker file. So literally I was like, all right, what can we build that we haven't already done? First, I'm going to show you again something in the context of what you know. We spun up web servers with Nginx. We copied some files down to a server, and we're able to display those things. Let's take the current Nginx container and let's use that as our base, and let's get some files in there. Let's get a site running via Nginx first, because that'll be quick and that'll kind of show you initially how you can use things that already exist. But then after that, I think I want to grab a random technology. I think I have one in mind that I don't even know if they have a container for it already, but maybe we'll run through, install it manually first, and just see if we can run through and get a working Docker version for it. It won't be, you know, production ready, but it'll run. So let's see if we can do that in the next 45 minutes. I think we can get through it, no problem. Does anyone have any questions before we get started? We'll get a little bit of water, you know, so that this is not a LaCroix day. Mostly because everyone drank up all the flavors I like. They left me with berry and like the cran raspberry. Hey, come on, man. You know, everyone knows I do this. I do this 4 nights a week. Like, I need to be hydrated with the flavors that I care about most, like passion fruit and lemon, which is the best one. And even lime will do. But I don't know. They leave me with stuff like coconut. Coconut might be my least favorite thing in the world after celery. Celery and then tomato. I mean, tomatoes are pretty low on that list, but coconut might be my least favorite thing. And people just keep leaving me with coconut. And it's pretty unacceptable. And I feel attacked every time it happens, but it's okay. You know? They always said if you ain't got no haters, you are in fact not popping. So, you know, I just take it as, you know, I got some haters, which means I must be popping. But when you are popping, you don't get any good LaCroix beverages, which is sad. I'm actually getting sad about it now because the normal water is not doing it for me. All right, let's close all this stuff. Let's head over to the Docker Hub. Hub.docker.com. We're gonna go ahead and write ourselves a quick Nginx thing here. We have a little trash Docker file here. We're gonna modify this Docker file. All right. So we're gonna do it from Nginx. We're gonna use Nginx as our base image. Whoa. Escape. Escape. What's happening? Oh, there we go. From Nginx. All right, so let's talk about what we're gonna do. We're gonna take, I'm gonna save this. We're gonna go to the Docker Hub. We know we wanna use the Nginx container. All right, we wanna base our stuff off of this. If you look on here, it will tell you how to kind of use it. Again, it takes a little while to get comfortable with. Tells you how you can, you know, host some simple static content. And look at their command. Look at their, I'll make this a little bit larger. Look at the command, example command that they give us. They give us a Docker run. So you've seen this before. Docker run is going to run a container based off this image. They're going to give it a name. They're going to call this container some Nginx. Then check this out. They do a -v. They say, go ahead and mount some content to user share Nginx HTML. And then this :RO, that just tells it what operations you're allowed to do. And then a -d, we know that runs it in a detached state, and then Nginx. So what I didn't show you is that you do not have to specify a volume. You can directly connect if you do it like this, you can directly connect a folder or directory on your host computer to a place in the container. So you can do that. You do not have to specify a volume, but you can specify a volume if you'd like. And you can actually specify a volume at a specific location if you'd like. But this is how you would do that. So basically what they're saying here is go ahead and put your site code in this folder on your computer. And then when you run this, it'll connect and then it'll use those files and it will serve up those files. So we can do that, but we'll do that first. Oh, never mind. It tells you exactly what to do. It says, alternatively, a simple Docker file can be used to generate a new image that includes all the necessary content, which is a much cleaner solution than the bound mount above. So I was going to say, this is a better solution. So what does this mean? Here, your files you do not have everything that you need. You do not have all of your dependencies and all of your libraries to run your code. You're actually missing the entire code base from this. It's the default Nginx code that's going to be using some local files to serve some content. But if we do this, we can build everything into our container. So let's actually grab, HTML5 up. This is where we grabbed stuff from last time. Let's grab a free HTML5 website. We're gonna scroll down. TXT, I like your name. So we're gonna download this. So you know what? Let's do this because let's do copy link address. All right, so how will we do something like this? So what I could do is, one way I could do this is I could download this file right here. Any way that you like, you could download it from the command line. I mean, from the browser if you'd like. All right, so this is actually a zip file. This download folder is actually a zip file. If I actually did unzip, nope, I'm not gonna do that yet. So this, all my site files are actually right here in this download thing. Let's practice using those things. So if you're looking at the Nginx repo, you might say, hey, where is like the default document root? Like are these files being served from? It's basically being served from here by default. It's being served from user share Nginx HTML directory. So it'll tell you that down here somewhere. If you look for it, it'll tell you where it's actually serving things from. So we're gonna go ahead and we're gonna copy. We need to copy our files into that exact location. So how can we do that? What did we learn yesterday? So we're gonna vim Docker file. So first thing we're gonna do from Nginx. Now we're gonna do a copy. All right, so first thing to know is that now that we've gone to a new major command that's turned red, a new command, this does implement a new layer. And so we're gonna copy download, because download is the name of the file that's listed here. Maybe I'll change the name in a second, so it makes a little more sense. So you're gonna copy this file, and you're gonna copy it to somewhere on the machine. So they said we copy things to user share Nginx HTML. Oh, I can't paste that? Really? Don't do this to me. I want to be able to copy and paste. User share Nginx HTML. If I can't, that's fine. Trash. All right, /user, wow. /user, okay, I'm gonna type without looking. User share, was it Nginx /HTML. All right, there we go. So we're gonna copy this downloads directory into this user share HTML directory. Is that all we need to do? No. So this download folder, this download file is actually a zip file, and we know that all the files that we need are inside of it. So what we can do is we can unzip it here if we'd like. Nah, I'm not doing that. We'll make a test file because I think it's just gonna stick everything in here. I'm going to copy, download into that test file. Let's see what happens when we unzip it. Unzip, download. Not unzip, unzip, download. All right, so it unzipped a bunch of files here, and we got our bunch of stuff here. Downloads is still here. And these are our site files. This is what we need. We can basically just serve this up here. So the first time you're building something like this, we'll get out of here. RF test. Couple things. You may not know, like right now, I have no idea what is already inside of that user share Nginx folder. God, like I don't know I'm not looking at this image. I don't know. I didn't build this Nginx image. I don't know what's in it. So you could run it with that run ITD command and log in and mess around and see what's in there to see what actions you need to take to make proper changes. But again, you could also do you could also do some run commands, but override the override the startup command to see what's in there. So let's say I wanted to see what existed inside of, actually I don't need it. I don't even need -it. I might need I and might need I. Docker run -I, nginx. Run. Oh, I don't actually have nginx, so hold on. Well, no, you know it'll download. So Docker run -I nginx, but I want to see what's in that user share nginx HTML folder. So I'm gonna do ls-user/user/share/HTML. I want to see what's in here. And I don't have it, so you know if you do a Docker run command, again, and you don't have that image locally, it will go ahead and download it for us. So while it's downloading, I'll answer some questions. New LaCroix flavors of celery and sea Adam. Like, that is disgusting. Celery and tomato. I'm coming around on tomatoes. I'm getting my grown-up taste buds. And tomatoes is, I can tell it's going to be something that I can tolerate soon, but not right now. Celery is all the way out. It doesn't even have any, good nutritional value. So it should just like not be a thing. Doesn't make no sense. You guys sound like you're talking big on a project. I'm in on that. What about bubbly? I've never had bubbly. They do not give us bubbly for free here. As much as I enjoy my LaCroix, I don't like sparkling water enough to pay for it. So I get it because it is free. What's up, Aaron T. Hall? How you doing? What's up? Yeah, we're doing a little bit of Docker tonight and next week as well. Why no paste? Yeah, I was holding Control-Shift-V. I don't know why it wouldn't let me paste. Also, what did I do here? It says download complete, but it doesn't look complete. Oh, that's just that. I don't know what happened over here. It also stopped my my server. Looks like we have a little bit of a networking issue on this laptop. My laptop is in fact not connected to Ethernet. Whoops. I broke it all. Hold on, it's coming back. Let's stop this. Oh, that should be back now. Oh, that's not back. Download it. That's weird. There really isn't good Wi-Fi over the side of the building that I'm on, but it should be able to download this, even though it says we have. That looks right. Oh, okay. Error. This is not what I was expecting. All right, there we go. All right, there we go. All good now. Cool. So now we downloaded that. So check this out. It ran the ls-la so I could see what's in this file. So in this folder, we have these two things here. We have the default nginx HTML and this 500 error HTML. No big deal. We don't want those to be there, so we're gonna remove them. We're just practicing commands. So what we want to do is we want to remove these files, and then we want to put our files where these files are, so that it knows what to do. So first, let's do this. First, let's do a Docker run -itd -p 80 nginx, just so we can see. This is basically going to run an nginx container that is exposed on my local machine that shows a default running version of nginx. So we get this welcome to nginx thing right here. All right, so we're going to stop that. All right, so what we're going to do now, let's edit our Docker file. We know that we want to remove everything that's in here. So let's add in a run command first. Let's start from the top. Run command allows you to execute a Linux command. And so we're gonna rm-rf/user/share/nginx slash HTML slash star. So I actually want to delete everything in there because I don't want none of that stuff. So this is going to be one layer. There's going to be a single layer that does this. And it's going to go through and it's going to remove that stuff. Next thing I want to do is I want to copy the thing that we downloaded to that directory. So I want to copy download, which is local to my computer. I want to copy it into the image at this location. So I want to put it in here. So after, what I need to do after I copy it in there, then I want to unzip it. Maybe I just want to use as many of the commands as we can. I want to use as many of the commands as we can use, just for practice. But how do we, instead of copying this to where this is, maybe we should set the work directory, because we're going to be doing everything in here. Work dir first. So instead of copying this here, we can take this, escape the over. We can exit it. All right. So if I set my work there, I actually don't need to do, if I do copy now, it should copy it right to, I actually don't know how to do this. Actually I don't know what the right, if I do dot, that seems right. We'll see, we'll check. I actually don't know how to specify like this location if I've already changed the work there. But I think this will work. So I'm gonna copy it here. Now I need to unzip it. So I'm gonna run unzip, download. And that's it. I think that's all we're gonna need to do. This is gonna put the files, it's gonna remove the files that are there. It's gonna set our work directory. It's gonna copy in our files to this location. It's gonna unzip it. And we should, maybe that'll work. So let's see. Let's see real quick. How do we build this? I'm gonna say Docker build. I'm gonna give it a name. I'm gonna give it -t, and I'm gonna say custom. What's up, easy life for me? Welcome to the channel. Thank you for the follow. I'm gonna call this custom Nginx. I'll put a dash in there. Custom Nginx is the image that we're gonna build. What's up, Jack Awesome? Jack Awesome. Welcome. Thank you for the follow. I went to Gets Larger so I could say your name properly. I couldn't really read it. It's like really small in the corner. What's up? How you doing tonight? So build -t, and then we need to build right here. Remember, you have to specify where the Docker file is that you want to build from. It is in this location. I'm gonna build it, and it's gonna go through. It says from Nginx. So it ran that, but it looks like it didn't do anything, so it was probably already cached. It did this. It moved forward, it ran all these things, and we got to the unzip download, and oh no, we got an error, unzip not found. So our build did not actually work, and you can confirm that by looking at your images. Docker images, and we get this none here. And these are very annoying. These are like super duper annoying. They fill up fast when you're failing, like when you're failing to build correctly, it doesn't tag properly. So this is basically like a broken image. It does not have what we want in it. I'll remove it later, but we do not see the image that we want, which is Nginx, custom Nginx. So unzip not there. So what can we do? Let's go ahead and see if we can fix that problem. How do you install things? So this might be another thing that you want to check. You might want to see like, hey, like I have no idea what the Nginx container, what it's using. Like, I don't know what it's built off of. I don't know which package manager is available to us. So again, this is an extra step. Like you either have to go look at the Docker file to determine that and see what it's based off of. So it's based off of Debian. I know that Debian distributions that are based off of Debian use the apt package manager. You could also again run another one of these. You could also run another like a run command that has I can just type in this like docker run -i nginx. I can do like apt and see if it gives me some output, and it does. It tells me how to use apps, so I know it's there. If I type in like yum, and I try to run it with Yum, it'll say, hey, not found. I don't know what that is. So that kind of, those are ways you can find out what tools you have available to you. Again, you can also spin up, you can also run this with /bin bash. So like I can do, I need a T. And I can do /bin/bash. And it will get me in here. Then I can see, you know, what to do. So when you do get an error, like we got during our build step, you can feel free, like 100%, feel free to log into a container or start up a container like this, you know, exec into a container and figure out how to install it. If I wasn't sure how to get unzip, you know, you type in unzip and you're like, oh, command's not found. Google, you know, how do I install unzip in Debian? I know you can do apt install unzip. And you might think you can do that by default. You might type that in and get this thing and think you're, oh no, like it's not working. This is not a Docker problem. We're out of the realm of Docker problems. These are all Linux problems. It says unable to locate package unzip. Again, these are designed to be as small as possible. To get the packages that you want and need, you're gonna have to do an update on a container. So it's actually super common. And we talked about learning a little bit about best practices. It's very common to, no matter what, when you are downloading, if you're going to be downloading any packages inside of your Docker container, you almost have to do an update. So first thing we're going to do is, we know we need to download something. We're going to do a run. We're going to do an apt update. And we know that we're gonna pass on -y, even though I don't think we're gonna need that. And we can do this in the same line so that it's inside of a single container or a single layer. And we can do apt install unzip. So you can see this is just a little like basic Linux script. Like we're literally just running down, saying the things that we want to do, like as if we were doing them manually on the computer. We're gonna start with this base image. We're gonna run an apt update and an apt install unzip. And again, this is another common thing. Remember, when you are installing things, if it's ever gonna ask you yes or no, you need to pass in that -y. Super annoying, but necessary. Then we're gonna remove those files that we get that are there by default. We're gonna specify a work directory. We're gonna copy something to that work directory. We're gonna unzip that file. So this, let's check this out. Oh, whoops, I didn't mean to do that. I meant to do another build. Let's try our build command again. Goes through. You can see here now it's doing up top, it's doing our apt update. And it's going through, and look, it unzipped everything. Then it let us know that it successfully built everything. And if we do a Docker images, we have this custom Nginx thing here. 10 seconds ago. What's up, Burger Man Can? I love burgers. I actually just had a burger. I haven't had a burger in a long time. I actually ate it without bread, which was sad. But you know, you gotta do what you gotta do when you have goals. But what's up, Burger Man Can? Thank you for the follow. Welcome to the channel. So let's see what happens when we try to spin up a container based off of this new thing that we built. So let's take the last thing we ran. So before we ran this Docker run ITD, we port 8080 for Nginx. Now let's run it for custom Nginx using our new thing that we built. We run it, and Nginx is now running. And if we refresh, ooh, sweet success! Look at that. That's beautiful. That is beautiful. So now we have this sweet application all set up and running that we grabbed pretty easily. So real quick, let's just use some other tools to do this. We downloaded this locally, and now it's required that when we do this build, that these files be local. Remember yesterday we said that instead, there's a lot of different ways to achieve exactly what we just achieved. I ran more things than I actually needed to run, but again, that's for practice. But we actually don't need to copy this in. We could use the add command and download it directly from the website if we had the URL. So we could do that. We're gonna do that in a second. I'm not going no carbs. I'm not going no carbs. I'm just watching. I'm watching my figure. So I'm just being conscious about what I'm eating. I'm cutting out a bunch of stuff. Has never worked for me, and right now, just kind of doing things in moderation has helped a lot, and it is working. It is easy. It's working and it's easy. I just decided not to eat the bread because I had some other stuff today, and it just a lot of extra bread today. But I have no problem eating bread. Yeah, I'm trying to, we're going to start doing hashtag Road to the Rock, Road to Dwayne The Rock Johnson. That's where I said I was going in the beginning of the year. Still, I mean, not really a goal, just a fun, he's a in shape dude, something to aspire to, but I'm just trying to be healthy. That's all. Okay. So let me, this is how web servers that are built, development goes on. Yes. So, let's just see the add command in action real quick. Cause we didn't need to copy this. We can just, we can actually add it. And I'm pretty sure I can just, for the add command, pretty sure I can just add, it's only dumb because like, it doesn't really change anything. It's just an add command instead. And I think I can take like, I copied this. Copy link address. And I'm pretty sure I could do something like this instead. So it doesn't really change our file. Let's see if when we build it again, if it works. And we can rebuild that. Add that failed. Oh, we have to add okay. So basically it got the same certificate error that we got. I actually don't want to dive into resolving this right now, but this does work. If this was a better site or the link that they gave us was better, their cert was working properly, wouldn't be a problem. I don't really want to look up how to resolve this with the add command. It's probably pretty easy, but that would work. You can see it did try to, in fact, download something. It did try to download something. So just want to show that you could grab it directly from online if you needed to. I don't know. I actually am a fan of not doing it this way. I'm a fan of, if you're going to be building something over and over again, I think that you should have all the necessary files inside of the repository that you're going to be using, because of things, let's say the internet goes out. There's a blip in the internet, blip in the network, or something like this. The site that you've been relying on to use their data has a crappy certificate or something weird happens with them. You can still build all of the things that you need to build. Doesn't stop you. I think that is that's great. So pretty simple. I'm going to push this up to Docker Hub. You guys can actually grab this. I could have also just unzip this locally here. Like actually could have like unzipped downloads here to its own folder or something, and just passed in all the files. Also an option. Again, I didn't need to download it there. You can make it work however you want. We just needed to get the files that we needed from either our computer or the internet into the container, into the image, and we did in fact do that. That's all great. But let's do this with a little bit bigger of an application. Let's do this with an application. Like this is a static website. We are running an application. I'm gonna push this up to Docker Hub so you can pull this down if you like and run it. You can simply just run Docker run and the name of the image that I send this, and you will have this locally on your computer. You'll be able to see this site locally on your computer. So let's do that. Let me show you how you push up to Docker Hub. All I do is I do Docker push and the name of the thing that I want to push. I have to log in first, so I lied to you. My problem is sometimes you automate yourself out of knowing what's going on. I no longer, the way I have things set up, for me, I don't have to do all of this to be able to get stuff up. I just have to push when I'm ready because I've already handled the login. But first thing you have to do to be able to push this stuff up to Docker Hub. So when I say push up to Docker Hub, hub.docker.com when you create an account. It basically is like GitHub. And so when I click repositories here, I have no repositories in this namespace. So I actually might have to create one first, but I don't know. But this is my space to be able to push these things. So if I do Docker login, it'll allow me to authenticate. So my username, I think, is mastermind.io. Password. All right, I just had to type and make sure it didn't. I had to make sure it didn't show my password, which I don't even know if this is my password. Not my password. Is this my username? Oh, try that again. Make sure I didn't type that in wrong. Okay, hold on. Let's try. Hold on. Let me figure out my password. I'm gonna log out. I may not be able to log back in. Log out. Oh, it's saved. Ah, yeah, I was being super secure. That makes sense. What is this? Why does it have 3 things? So, actually, here we go. I'll just, LastPass. You should use LastPass if you want secure passwords. Copy password. All right, so I'm gonna log in. I'm gonna do mastermind.io. I'm gonna paste in my password. Login succeeded. So now that I've successfully authenticated with Docker, I can run that push command. That is not the push command because I misspelled push. All right, no, okay. Just Docker push custom Nginx. What? Okay, so I guess I do need to create request access to the resources denied. So maybe I do have to create a thing. I didn't know. I didn't think I had to do this. I thought it would take it by default. But just like this is just like a GitHub. So my repositories. Click on repositories. Click create repository. I guess I'll call this custom -nginx. Description, stream, custom, Nginx, site, public. Oh man, I gotta like reconnect. This is whack. This is too much work. I just wanted this to be fast so I could build something else. Authorize. Okay. Now if I go back to repositories, create, custom, description, mastermind, academy, custom, Nginx, site example. That sounds right. Connected, create. What's up, Mouse Potato? Welcome to the channel. Thank you for the follow. Cool. So here we go. So basically when you tag these tags, the tags now, the way the namespaces work in Docker, it's actually kind of your account slash the, basically your account slash the name of the image, colon, the tag name, so the version, or whatever you want to tag it with. Latest is what it is by default. I'll have to tag it this first, but if I do a Docker images, you can see here I have custom Nginx and the tag is the latest. So I can do Docker push. This is going to be latest, but I have to tag it this first. So how do I change the tag? How do I make this custom Nginx? How do I make custom Nginx latest this? Because it has to know this namespace tells it where to get pushed to. I have to do this. So I have to say, hey, Docker, tag this with this name. So if I do another Docker PS or Docker images, I'll now see that this doesn't go anywhere. This is still here, but now I have the same image tagged to something else. So both of these tags are referencing the same thing. You can see that the same font, the same size, same created time, same actual image ID, just different tag names, repository names. And so now if we do a Docker push, it goes ahead and it uploads all of this to that repository that we made. Again, very much like GitHub. And now you will all be able to grab this. You all will be able to grab this image. And so that's what's nice about it. Like you can develop something and you can just, I can give you, you can just do a Docker pull. So now if any of you run this, public view, if any of you run, I will paste it in the channel. If any of you run Docker pull, oops. Not even Docker pull. You run Docker run -itd -p8080. Is that a colon? No, that's not a colon. 8080 mastermind some Nginx. If any of you run that command right there that I just pasted, it should pull it down for you. It should start up on port 80, and you should in fact see this site right here exactly as we have built it, which is super duper nice. Super duper easy, super duper nice. So try it out if you want. If you already have something running on port 80, remember that won't work. So you may have to change the port or stop the other thing. But that should in fact work for you because this is a public thing here. And yeah, it's really nice. You can share these things for people to use. So that is one thing, but let's try a different, let's try a little bit harder of a, I don't know, a little bit harder of a thing. Let's do, I'm trying to think of applications that I've used that I like. Everyone always goes, like the examples always go to WordPress because WordPress has a number of different technologies that are needed to run it. And that is a really good thing for Docker Compose. So I'm gonna wait to use that as the first initial Docker Compose example. But maybe a CMS, I've used a CMS called Strappy, which I like, which is like a open source headless CMS that I don't think needs much to run it. It's a Node.js application. It's pretty cool, actually. And I actually think we're going to use this. Actually, we're going to use Strappy as a backend data source for that thing I want to build. We don't need a backend data source like this, but I don't know. I think it might be easier for some people to mess with, but we'll see. But this is just a Node.js application, so they actually might already have a Docker file in here. I assume they would. Let's see. I do not see a Docker file here, so this is good. Maybe we will Dockerize this for them. Huh. Interesting. Let's actually check hub.docker.com. Someone had to do like any open source thing, like, oh yeah, so they have, okay, they have an official Docker image. Okay. All right, nice. How to use it. They give us a way to use it. So here's what we're gonna do. This is gonna use a SQLite database. Okay. So, all right, there's an art to Dockerizing things. There's an art to it. And I said we're gonna talk about best practices. So let's actually go ahead and take a look at what their Docker file looks like. And I'll run it so that you guys can see what Strappy looks like. It's a web application that allows you to manage content. Super nice. But, well, that's very simple actually. They're using their entry point script. So look at this. This is a very simple thing. You've kind of seen these things here already. Looks like they already have they already have a Strappy base. Okay, that makes a little more sense. I was like, they have a lot of configuration options. They're probably using this and that. Let's check out Strappy base really quick. I would like to see what that looks like. Uh-oh. Did we lose internet or did it's down? All right, so let's look at Strappy's account. Strappy base. So this is what they're basing their stuff off of. Looks like they have a bunch of stuff. Oh, look at this. Hiring test API. Hold on. We might get a job over here. If I can't see the whack. I want to see the We're gonna look at that. We're gonna look at that one day. We're not gonna look at that now. Very interesting. Man, Docker Hub does not like you going back one. This is very slow. Let's see. Come on, come on, come on. Yeah, it does not like you going back. I'm gonna tell them about themselves. Tell them we can fix it. We can fix it as a team on stream. Let's see what their base image looks like, because they're not gonna let me see this either. All right, can I see it on GitHub? I would rather see it. So I gotta still not that much here. What are they basing this off of? Image history. Let me. Darn it. I guess there's a. Don't give me an easy way. Command add file. This is what was added. This is not the full. Not the full thing. All right. I thought I would be able to easily see their base image. It looks like they have a layer that they're hiding from us. Maybe. There's probably a way for me to see it, but I don't know what it is offhand. All right, let's go back to Strappy real quick. So Strappy is a Node.js application. I'm gonna go ahead and just run it real quick because I have Node. I'm pretty sure I have Node already installed on here. Let you know what to do here. Actually, install Yarn with these docs. I actually don't have Yarn, so maybe we won't do this. Below and Debian stable, you need to configure the node source. Simply Debian. All right, we'll try it. We'll try it real quick. If it fails, we'll do either something else or we won't do anything else because we've done a lot and things are overwhelming sometimes. Well, let's check it out. And echo deb. But I'm going to install it really quick. I'm going to install it really quick via like the real way that you kind of get it installed so that you can see it running. And then we'll try to Dockerize it real fast. I think it'll be quick. I think it'll be really quick, honestly, because there's already a node folder. But this may fail. We may not be able to do this, but we're going to try it out anyway. And it's going to be exciting. Does anyone have any questions so far about what we've done? I think we've actually covered again, there's a lot of intricacies that still exist, but that I don't necessarily think are super duper important to dive into. High level things that you need to understand again about containers are these isolated ways to run applications that have all of the necessary dependencies and libraries kind of packaged up to be able to run an application. You need to know things like that they're ephemeral, so they don't persist data by default. You have to do something to make sure that data sticks around. How can you do that? You can use volumes to connect the container to a local storage place. You can also connect local storage directories directly to a Docker container as well. So that's how you can handle that. We know the differences between images and containers now. We know that image is the thing that we're going to be using to deploy containers, and one image can produce many containers. We know that to build an image, we use something called a Docker file, which is great. So we configure the way that this image is going to be via a Docker file using those pretty simple commands. Actually, again, especially if you have a good handle on Linux, it's actually really easy to write Docker files. So I would recommend getting a decent handle on Linux and practice installing some programs, things manually. It'll really help when you're trying to build out a Docker file, because you're essentially doing the same thing. You're essentially installing this thing. You're installing all of your libraries and binaries inside the container almost manually, unless you have a base image that has those things available for you. We learned a little bit about management of these things. We learned that you can stop a container and it'll actually still be on your machine. To get it to go away, you have to remove it. So, even though it's running a process After the process dies, the container exits. It still exists on your machine, and you have to clean that up. We also learned that these images that are built, if you cannot remove them unless you've removed all of the associated images with them from them, both running and stopped. Those are kind of the core elementary Docker concepts that you kind of just need to know to kind of understand how things work in Docker. The best way to use it is play around. Again, also to add to that, that they're isolated. So for you to get data out of them, to be able to connect them to, the host machine and expose things, you have to expose ports. And then if you want to be able to access them via your host machine, you have to map those ports to a port that's on your host machine as well. That the Docker run command has a bunch of different flags. We learned that you need to add in the -D flag to get it to run in the background and to run consistently, and to persist, honestly, to keep running. We learned about some of the other flags that we need to run, like -I for interactive mode and -T for TTY. So far those are kind of the main things. Tells you use port 1337, project command that is. It was 1337, that's the delete Haxor number. Let's see. What are we doing? Did I pull this already? What did I do? It spells lead, delete. I think I actually have that on my, see, they're smart. Look at this. Look at this. First off, I didn't tell you guys that Terrence, I'm sorry, bro, gotta throw you under the bus a little bit. You guys know about, that's spell this wrong. Master. You guys know about lead Haxors. I put this on the website. Hold on. Master. What's up, Carlos Sarts _. Don't forget the _. Welcome to the channel. Thank you for the follow. Check this out. I put this on here, and Terrence didn't catch this. He was like, "Oh, bro, you left some random." He's like, "You left some code on your site. You didn't clean it up." And I was like, "No, I did not. You are not Elite Haxor, obviously, because you didn't know about Elite speak, okay?" So, sorry, Terrence. I didn't mean it to be mean, but he didn't know. He didn't know. He thought it was an error. But I do respect that he was trying to make sure the site was better, and he said, "You gotta fix that, bro." And I said, "No, you've got to fix that, bro." Let's see. What is DevOps? I'll ask that again in a little bit, and I'll go through it, or I'll point you to the episode 1 where you can find all out about that. You want to be called? They call me Overscore. I like that. Uno Plank Overscore. I like that. You got a nickname now. All right, let's see if we can do this real quick. If we can't do it real quick, then it'll be like super fine, and I don't care. Let's make a new directory called Strappy. And I wanted you to see me install it locally so that I could install it manually. Open source, Strappy. I thought I was on the take me here. And from here, take me here. They do have a Docker file. Oh, Strappy Docker is a whole. Okay, I was very confused. I was like, bro, why does the main Strappy not have a Docker file? That makes sense. Okay, they have a whole separate repo for that. All good. Here's what we're gonna do. We are going to follow what they say. Yarn, create Strappy, my project, quick start. We're gonna copy exactly what they have here. We ain't doing nothing special. Not a darn thing special. Look at that. You don't even need to know what's going on right now. This is built from Node.js. And they're using some tools that are a part of Node to be able to install files and install binaries and libraries. So this is what we're talking about. Actually, this is a perfect point. This is exactly what Docker solves. This is a problem that it solves. So you see me now having to go in and run this stuff, and all these things are getting, like, installing all these dependencies, fetching packages. All the stuff is getting installed on my computer. And it's giving me a very specific version of things, all that stuff. I would be responsible for keeping these things up to date as we kind of built things out. Let's say I started working on this Strappy project before you did. And did I break it? I didn't. Trouble, man, my network is dying. Let's say I started working on this before you did. Say I started working on it a couple months ago. I've been developing this app against the current packages that I've downloaded. It even tells me that my Yarn version is out of date here. And then you come along and I give you the same stuff and everything is all updated now and everything's all great. And we start to see, it's very likely that we'll see separate functionality. Not very likely, but it's common to see different functionality. I may see something that's broken that you see as fine, or vice versa. And it can be really annoying. Imagine if you have 20 developers all working on a project. They've got all these things installed manually on their machine and versions and stuff like that. But all this stuff differs from what is actually Whoa, that was fast. That was really a quick start. Dang. That was, okay, never mind. This was a bad example because I was hoping this would be hard to install manually. But imagine we're doing that, and there can be a lot of mismatches, and there can be, maybe we upgrade the version in prod to delete some security, to solve a security vulnerability, but now you didn't go in manually on your machine and update it, and now there's all kinds of confusion, there's all kinds of mismatched packages, things like that. Docker solves those things because you define them via the Docker file, so it's always going to be the same, it's always consistent, it's always great. What's up, Autumn the Creator? What's up, Dijon Codes? Welcome to the channel. To you both, appreciate you being here. But look at that, that was fast, actually. That was really nice. But look at all that. I had to install Yarn. I had to run 3 commands before I could even get this going. I had to, Google some stuff and figure out how to get Yarn installed and all that crap. I had to worry about that. And any other computer I need to go to, if my computer breaks and I need to come back in and run this application, I have to actually reinstall all these things. Wouldn't it just be better if we could build this process, and next time I get a new computer, or if anyone else wants to use it, I simply install Docker, and I simply run Docker pull Strappy or whatever, and it works. It's super nice. But actually, there's actually no point in going through this. That was very easy. I thought I was gonna have to manually username, mastermind. I thought I was gonna do a bunch of cool stuff. I'm gonna use the suggested password. This is local to my machine. You can't get to it. And it doesn't matter because it's gonna be destroyed in 2 seconds anyway. Wow, look at that. Dashboard. I thought that was gonna be tough. Man. All right, so Strappy is just you can build these content types, and it helps you manage your data. This is actually gonna be super boring now, but let's see if we can run the actually, instead of building our own, I will show you that let's grab their let's download their Strappy Docker version. Install and run your first Strappy project using Docker. So let's actually download this. Let's clone this. And let's download this actually. So I'm gonna stop this, and I believe that should have stopped this. No, this users. Yeah, it's broke now. Cool. That makes sense. What was I doing? Let's get out of here. CD dot. I'm gonna git clone this. Git clone Strappy Docker. And we'll get the Strappy Docker thing here. CD Strappy Docker. All right, so look at all the stuff that they have in here. And so let's take a look at the Docker file, because I think it might be more powerful now that we're in here to look at the Docker file. I don't know where it is, but Gotta be. All right, so Docker file's here. Let's take a look at this Docker file. So, the Docker file argument is a base version, I guess. I actually don't know what an arg is. I'm assuming it's like a is it an arg from the entry? I actually don't know what arg is. I've actually never used an arg in my life for a Docker file. I wonder if it's new, or if I just don't know about it. Docker arg. I mean, I'm sure it's an argument, but it looks like I was going to say, is it just an environment variable? Well, let's see. I want to see if it's Docker arg versus env. Arg and env can be confusing. Both are Docker file instructions which help you define variables. So, okay, so it's like an env, and they feel pretty similar. Env is for future running containers. Arg is for building your Docker image. Okay, let's see if we can break this down. What's up, Nathan Bumpo? Welcome to the channel. What's up, Blockquid? Welcome to the channel. Thank you for the follow. Glad to have you here. It's very exciting. So the args are available. The args are available for you to use during the build time. So the args are here. If you pass in an environment variable, those are variables that kind of sit around waiting for the image to actually be run, for you to actually start up a container. And that's when env variables looks like they take place. You can't change env directly in the build, but I guess you can with arg. Okay. We'll see. Okay, so we have an environment variable here, which is the base version here. From Strapi base version, another arg here, Strapi version. So I ran that yarn command, and they're basically running that same yarn command in here. Yarn again is just it's a tool for Node.js to be able to. It's like a script runner, and like it gets it's like a package manager. All kinds of stuff, but it grabs all the dependencies and stuff that are necessary for a Node.js application, sets a work directory, creates a volume, it copies this entry point.sh to user local bin, and then it creates an entry point and a CMD. So the entry point, when we execute this, it's actually going to execute this entry point.sh file, and it's going to run Strapi develop basically. So let's look at this Docker entry point file. So this is a common paradigm. If you need things to be executed when a container starts, if you need to set up variables, give them values, if you need to set things up, start things up, you can use these entry point scripts. So let's take a look at this. It's a simple sh script, and it might do a bunch of stuff, it might not. And so it looks like they actually are using this to set up all this stuff at runtime, database client, extra arguments if you pass them. But don't sweat it. This is just a bash script that you might need to use to set some things up. So just know that this is a common paradigm. This is a best practice to use an entry point script to do, rather than to use an entry point script to do the kind of runtime configuration rather than building a lot of that stuff into the image itself. And honestly, sometimes you can't build those things in the image because of the paradigm in which things run. But let's, is it copying anything in? Is the Docker file copying anything in besides the entry point? No, it's not. That's interesting. So what this tells me actually is that everything must be here. Must be already in the base. This is interesting, actually. What's in the rest of the directory? Like, why is all the rest of this stuff here? Oh, it's multi-stage. Okay. Oh, got it. I think I got it. There's multiple Docker files in here. And that was at a base. That makes a little bit of sense. Hold on. I'm just trying to see something really quick. It just tells you how to set up some examples here. What in the world? Okay. I want to see something really quick. Let's actually build this. So we can build this manually ourselves rather than pulling the image. You can actually build it yourself. So we can do a Docker build -t. I'll call this Strapi build, and I'll tell it to build right here. Step one, arg-based, invalid reference format. So I need to pass in something. Let me see something here. Do they tell me in the README what to do? I just don't know the structure of this project. All right, here we go. I should just read the README. You should always read the README first. I was messing around because, again, I think it's fun to explore sometimes. But you should read the README first to know what's going on. Again, that README.markdown file will basically be this down here, and it'll tell you how to use it. It'll tell you what's going on. But I wanted to see if I could just figure it out myself, which I failed at. So use Strappy to create a new project. Strappy comes with two images, base and Strappy. Use Strappy to create a new project or run a project on your host machine. Use Strappy base to build a Docker file and create an image for your app. Okay, so you gotta use both. The default command. Man, this is actually a weird thing where it's actually, this feels more complicated. It feels more complicated to do it this way, which sometimes it is. Sometimes it is, like, containerization's not easier. It definitely is not simpler. It does provide for simpler management. I find every use case is not a use case for containers. Every use case isn't. You can ham fist anything into a container. But so generally things like databases, like, so right now they're actually going to be using a container to do some SQLite stuff. Databases, if I were you, I would never ever in a serious situation use containers for databases. Again, why? We said these things are ephemeral. Databases are a incredibly persistent data store. You want those to work super well. Now, you can make it work. It works. It does work. I think you get zero benefit from, I wouldn't say zero benefit. I think that you don't get as much benefit as everything else from running something like that in a container. I would run a normal database, not containerized. There are a number of applications actually that I would not run containerized, but yeah. We could just take this. If I ran this, it would basically work. I would have to change this. It will work, but that's annoying. Actually, let's run it. That was actually, they set that up very easy. Nope. I'll just do, what do I have in this folder? I have, where am I? All right, I'm just gonna put these files in a random spot. Well, you know what? I'll run it. PWD project name. I wonder if it'll create this directory. If I have to create the directory, I probably have to create it. We'll see if this works. I can't remember if it'll create this project name directory for me. Well, I should have had one to change it, but I want to see if we get the same thing. Or if it's as easy to run. I just want to see if there's any weird options. So one thing that is interesting about building Docker files, and again, a frozen thing here. What's interesting about building Docker files is you have to build it in a way. You can see here, there's these environment variables that are down here. You can't, to have a good Docker image, you can't just make the application run in the container. You can't just install it, make it run. I mean, you can, that is Dockerizing it, but the concept of Dockerizing an application is bigger than that. You need to make it configurable. So you need to think about it a bit. You need to make it so that anyone else could take this image from you and make sure that they have their information. They could pass in their information, and these things work properly, and they can use this image. So you can see here below, if I wanted to use something different from SQLite and I wanted to use Postgres or something, you can use, this is just a Docker run command, but you can use -e to pass in environment variables. This container was built to be configurable. It was built so that you, the user, can pass in the information that you need to pass in that describes your setup, your instances, and you can use this application. Again, there's an art to it a little bit to make it, to know how to do that, to know all the configuration items that you need to kind of expose. That can take some time to get good at. But it is more than just installing the application and all of its dependencies inside of the thing. Also, this is another reason why you don't want to use commit when you're building these things. Using the Docker file, you can find out a lot of these things, again, like the setting up of the environment variables and things like that. You can see in a Docker file, making sure you remember what things need to go on is another reason why you shouldn't build it manually and commit them. So let's see if this came back. It did. What is this doing? Oh, is it building? This is interesting. Very, very interesting. It downloaded so it pulled this. But is it pulling this too? Oh, this is just the output from running the container. Got it. So same thing, actually. Same exact thing. That's whack. Not whack. It's actually pretty cool. But they made it too easy. It's whack because they made it too easy. I wanted it to be difficult for us, but they made it super easy, and it ruined what I thought was going to be great. But all good. All right, so what time is it? 10:23. Cool. Does anyone have any questions? I can answer that DevOps question now. Yeah, let's see. I was following everything tonight until Leet Speak. What? I don't know. Leet Speak is it's a thing. It was a thing. It definitely was a thing. Yeah, it was definitely before memes were memes, for sure. Glad you're here, Dijon Codes. You pass arguments via the Docker build command. Yes. Okay. Yes, that makes sense. So if I were to run, like a Docker build, I could like pass in blah 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 blah. That makes sense. I like that. You get it at runtime. I never used those before. I will utilize those now. I wonder when they implemented that. Because I did not know about that before. Let's see. Are there any use cases for ephemeral DBs? Definitely Redis. Redis could be one. I wouldn't count. I generally don't include Redis when people talk about DBs. I generally don't include that in what I'm thinking about. So there are a lot of people who for the development process, especially for local development, Scriptify, especially if you have a project where your database is actually pretty small. Actually, a couple reasons, actually. So, if you can quickly import a database, if your database is small, you can quickly import it. So, if you're building an application, let's go to GitHub. If you're building an application and you're setting up these pipelines, a common paradigm that some people like to have in their project is every time someone creates a new branch. Let's go back to Strappy. Every time a developer creates a new branch, a feature branch or something, a common paradigm using containers, especially because they're so kind of deployable and scalable, easy to set up. Is, let's say they made one of these branches, a chore refactor config branch. A common paradigm is for when this gets put in, it goes through a build process, and a custom environment, a brand new environment, is spun up, with a new domain. So it might be like if this was the website, if the website was mastermind.io. And the branch that we want to see is CLI-starter, I will be able to go to like CLI-starter.mastermind.io, and I will be able to see that exact code running. So if you do have a case where your database is small or you figured out how to quickly import things, it is common to do ephemeral databases because you can spin up the process super quick via containers. Had an entry point script or something to import a database to quickly see that thing that is short-lived. I have seen that done. It makes sense sometimes. It all depends upon how your data set up, but pretty much I've only ever seen it for development purposes, for speedy development purposes. Can't really think of anything outside of that. But yeah, and that's actually I actually am going to try, if we have time during the Circle CI section, I'm going to try to do something like that. We're going to be setting up a whole build pipeline so people kind of understand the CI/CD process. But I think it would be cool to do to take it a step further and do some custom setups like that, where we're deploying full environments via new branches, which is really cool. But that might also be like I'll figure out if I think I can get it done in time and actually make it useful. If not, we'll try to maybe we'll set up. We got a few workshops coming up, like weekend workshops, like 4 to 5 hour, like Saturday morning workshops that I'm gonna be announcing. But maybe I'll add that in and maybe spend some time doing like, all right, go watch the introduction to CI/CD first, and then come and let's build like a real thing. Like we're gonna be building a real thing, but a much more in-depth build pipeline. Maybe we'll do something like that. But that's all I got. That's all I got for y'all tonight. I hope that so far you're following how to use Docker and why you would use Docker. The use cases can be interesting. It's okay if you don't see the value in it yet. Or if you don't see the value in a period, just trying to understand kind of what it does and kind of how it works is great. It'll feel better when we're running these at scale. When we're using a container orchestrator to manage these, we're able to do more with them faster. It won't feel so cumbersome, and I think it'll start to feel like more of the product that everyone seems to be so excited about. Because containers are pretty dope. But yeah, that's all I got for you. We're take a look at the stuff that we've gone over, read a little more about Docker containers, play around, see if you can get your favorite application or something to run. Almost every open source application you're going to come across is going to have a Docker file in the repo. I mean, like everything is going to have it. Everything's gonna have it. So see if you can find something that you like to use, and see if you can, see if you can either try to make a Docker file, maybe even go back to the scripting lab, the Bash scripting lab, and maybe take that script out of GitHub. Maybe just do that. Maybe take the script out of GitHub and let's see, Checkpoint Lab or Bash Lab? Checkpoint. I think it's the same thing. Maybe you take this and maybe you Dockerize this Bash script that we wrote. Try that out so that you can run it in a container. It kicks off, it does everything that it needs to do, and it exits. Might be cool, just to kind of get some practice. But yeah, that's all I got. Any other questions? What are we using as a guide? What are we using as a guide for what specifically? For the entire bootcamp? For Docker specifically? I can give you for anyone who came in late, I can give you the slides for tonight. I pasted it earlier, but or repasted it. But what are you referring to for the guide in particular? Not share. No, share as well. And then with the link from view, you can copy that to kind of go through to cover some of the. So you can go through. You can go through this. The slides to kind of get a little bit of help on like what each of this stuff, like a few different like introductory Docker things. For a guide to like get you going, I really think the Docker I think you should start with the Docker documentation. And I think watching the last episode and this one will give you enough to kind of get going, to kind of make something. I think this is what gets hard about learning DevOps things. I find it much harder to be like, you know, whereas in programming they're like, oh, go build a project that you care about. Like here it's like, go find someone else's project that you like and, you know, make changes to it. Like it's more of that than going out and do your own passion project. But yeah. So we'll dive even deeper. So you saw how annoying it was to kind of kick off all these individual Docker containers and have to remove them manually, all that other stuff. What if you could, I actually left out a big piece tonight. I left out Docker networking and linking, but that's okay. That's okay, because that's something that we can talk about that you get kind of out of the box with Docker Compose next time. Maybe we'll start with that. That's how containers kind of communicate between each other. But we will get to that. We'll for sure talk about all that next week. Compose, Swarm, Kubernetes. Kubernetes is the big one. We'll start Kubernetes at the. I think we're going to take Sunday will be a long stream. Sunday will be a 3-hour stream for sure. But we're gonna go over Compose and Swarm and like orchestration as a whole thing in early, and then we're gonna try to get through as much of the intro to Kubernetes as possible on Sunday, because it'll free up a lot of Tuesday to be able to actually write some Kubernetes YAML and like deploy some local applications at relative scale. So yeah, that is it. That's all I got for tonight. Tomorrow, if you are interested in the Python Bootcamp, we got, actually don't know yet. We have some algorithms. We just learned about classes and object-oriented programming. We're gonna do some exorcism.io problems. We're gonna learn some algorithmic problem-solving tools to solve things using these object-oriented programming concepts. And that's what we'll be doing tomorrow, all code. Tomorrow will be all code, all channel. I mean, for the whole 2 hours, 3 hours, will be all code. That'll be exciting. And then we're on to some projects next week. So next week is dope because it's Python projects. We're building, we're building a blackjack game, as most people do as their first project, as well as all the, Docker Compose, Kubernetes stuff. So pretty exciting. Friday, we are doing office hours on Overwatch. We will be playing some games, having some fun, talking tech. Come with your questions. Come to chill. If you want to play Overwatch with me, a bunch of people played with me last time, or any other game that you want to throw out there, hopefully I have it, and we can just play and relax for a little bit, talk about lives. What time Friday? It's always a hard one. Definitely by 8. But I really am probably going to log on. As long as I stay on my schedule and I work out in the morning, I'll probably log on early, like 6:30, so I can play some Overwatch, not by myself, but like get some practice in. I don't get to get any genuine practice in anymore. So I'll just be on for a while. I'm just relaxing. So whenever people want to join, probably 6:30 to 7 is when we'll start. Go till whenever, go till we get tired, go till whatever. What's up, Disc 105? You are, your nickname is Raid. All right. Hello, welcome to the channel. Thank you for the follow. We are actually wrapping. We're wrapping for the night, unfortunately. Anyone waiting on last week's videos on YouTube, those will go up tonight. Those go up on there. I'm going to upload them right after this. They are rendered out. So you'll have those if you're trying to catch up, if you missed anything last week. Yeah, that's it. They're writing Docker files and Docker Compose files. Yes. So, we, tonight was just part 2 of Docker, just kind of learning the basics of Docker, just getting hands on, at writing, we wrote some very simple Docker files and kind of just learned about persisting data, learned about, just different ways you could do things like that, getting information, managing containers, stuff like that. We're going to be doing Docker Compose and Kubernetes next week. So yes, we're doing Kubernetes next week. You can head over to academy.mastermind.io to kind of see the schedule. if you want to see it, I can paste it in the chat. Where is it? Curriculum, DevOps. We are going to be doing. Yeah, it's what we're going to be doing next week. So learning about container orchestration, as well as Kubernetes. We're going to do intro to Kubernetes on Sunday, and on Tuesday we're going to be doing all Kubernetes. So I'll send this over if you want to check it out. But yes, yep, I'm here for it. Yeah, if anyone has questions, I'm here for the questions. I'm not in a rush to get out of here. We're done with tonight's lesson. I want to let people go. I know everyone has families, has beds to get back to, so feel free to head out if you're here for the lesson only. Thoughts on Kubernetes versus Docker Swarm? Because specifically of Minikube, I think that Docker Swarm is not. I don't think Docker Swarm is a job skill. I don't think it's just not something that people use professionally. I think it's a great development tool. It's gained a lot of resources. It's emulated a lot of the great things about Kubernetes. I think people have kind of defaulted to using Docker Compose for local development, and then Kubernetes, Minikube and Kubernetes for bigger things, Minikube for local development. But I think Kubernetes is wins that fight every time. It is a bigger lift to learn. Swarm is easier to learn. Swarm does everything that you want it to do, but Swarm is missing some, or was, I haven't used it in a while. It was missing a bunch of features that people needed, and that's why I kind of lost so quickly, because Swarm is something that Docker put out, which should have been great, but Kubernetes actually did it a bit better. But yeah, Kubernetes is, I would focus my energy on Kubernetes, to be honest, over Swarm. But Swarm's cool. Swarm has so many, Swarm has really picked up a lot of the stuff that Kubernetes has to make it more useful. So it's a usable tool, but Kubernetes is what I would go with. What's up, Ferrickberg? What's up, man? Or lady or person, I'm sorry. I say man a lot, I say guy a lot. I'll chill out with that. I'll do better. What's up? I don't want to assume. I don't know what you guys are doing. More like Frackberg. Oh, yeah. Yes. Person, yes. Like fracking. Okay. You're out here destroying the earth, okay? I don't condone fracking, okay? I don't know much about it, but I know that I don't condone it. Okay, that's all I got. Who's online tonight? We got anyone cool online tonight? Anyone have anyone fun to raid? I don't know. BJJ. Who is this? Who is this person? Oh, Vape Juice Jordan. Yeah, okay. Yeah, is he on? He is on. We'll head over to Vape Juice. Definitely. Thank you, Adam. Appreciate it. Thanks everyone for stopping by. Thanks everyone for partaking and being my friend. I appreciate you all. I have a good time doing this stuff, like I said. So we're gonna head over to Vape Juice Jordan. Let him know I said hi. I'm gonna stick around. I'm doing a little bit of work, getting the stuff uploaded. So I'll be there, talking, having a little bit of fun. But yeah, I'll see you all tomorrow. Raid channel. Vape Juice Jordan's name is just so long to type. Jordan. All right, heading over. And in 7 seconds, and 6, and 5, and 4, 3, 2, 1. Let's go ahead and get the raid going. Everyone have a great night. Peace.